So we are looking with the periodic trends in the modern periodic table. So we have studied about the valency. Now we are going to see, as we have studied about the valency, how the valency gets vary in the periodic table, in the modern periodic table. तो एक बार फिर से देख लेते हैं कि क्या होता है वैलेंसी. So as we have given that we have to write down the electronic configuration for the elements of the group 1, and also we have to see what the trend occurs in the uh, electronic configuration of the along the period. So we have noticed that along the group, the valence electron at the outermost shell, that is the valence electron, remains same for all the elements which are in the same group. That means, तो यहाँ पर क्या कहा गया है? So if we are considering the valence electrons for all the elements in the same group, that is the group 1, so that comes to be 1. That means all the elements which are present in the group, that all are having the same valence electron, that is 1 or for the group 1, then 2 for the group 2, 3 for group 3, and 4, and similarly uh, for up to the 18 groups. And if we move along the period, so if we see that the number of shells in which the electrons are present, so that shell number remains constant. So this is basically the trend which is observed. So now let's see forward. So here we have given the electronic configuration of the potassium, that is 2881, and valence electrons 1. तो एक चीज और यहाँ पर जो इम्पोर्टेंट है कि इलेक्ट्रॉनिक कॉन्फ़िगरेशन कैसे लिखना है. So that is the one of the major part. Suppose I want to write down the electronic configuration for the element Na, sodium. So as I know, for writing down the electronic configuration, I should know कि उसका इलेक्ट्रॉन जो एटॉमिक नंबर है वो मुझे पता होना चाहिए. So as I know that sodium is having the electron atomic number, as we can see here, that is the 11. So as I know that atomic number of the sodium is 11, so as per we have seen here that the number of electrons which can be occupied, that having the electron capacity in the K shell to be 2, then L shell to be 8, then M shell to be 18. So according to this, if I want to write down the electronic configuration for the element of sodium which is having the atomic number 11, so it will become to be, that will be the 2 electrons in the first shell, that is the K, then 8 electrons in the next shell, that is 8 plus 2, 10. So 10 electrons I have placed. And here we can see that the octet is complete as 8 electrons, but the 1 electron which is remaining, that is the valence electron. So the 1 electron will be at the valence shell. So this will be the electronic configuration for the sodium metal. So as we can see that the elements which are placed in the group 1 showing the valence electron as 1 at their valence shell. If we are write down the configuration for the hydrogen, that hydrogen is having only the one atomic number, so electronic configuration is 1. If we write down for the lithium, then lithium will have, that will be the 2 comma 1, that is 3, as lithium is having the atomic number 3, electronic configuration 2 comma 1. Here we have seen that for the sodium 2, 8 and 1. Then if we write down for the potassium, as we have seen here, that potassium electronic configuration is given 2, 8, 8, 1. So valence electrons coming to be 1. We have seen here the trend that valence electrons are the electrons which are present in the last shell, that is the outermost orbit. And we have seen that all the valence electrons has coming to be 1. So this is the trend which we have seen here. So आगे क्या बोला गया है देखते हैं. So this is all about the valence electrons and valency which we have studied. नाउ तो आगे पार्ट आता है एटॉमिक साइज का। सो एटॉमिक साइज में क्या है, यू हैव सीन इन द प्रीवियस स्टैंडर्ड दैट द साइज वॉल्यूम इज द फंडामेंटल प्रॉपर्टी ऑफ द मैटर। सो मैटर जो कि हमने इस स्टार्टिंग में इस लेक्चर के इस चैप्टर के स्टार्टिंग में हमने देखा था कि मैटर क्या है। So anything that occupies the space and has a mass, it is called as a matter. Matter is all the things which we can see in our surrounding that are present around us. Suppose if we consider for the human being also as we, so we are also considered to be as the matter because we are having some mass and we occupy some space in this surrounding. So that is the matter. So we have seen that here is given that you have seen in the previous standard that the size वॉल्यूम इज द फंडामेंटल प्रॉपर्टी ऑफ द मैटर। यानी मैटर की जो फंडामेंटल प्रॉपर्टी है वो एक तो साइज या वॉल्यूम है। द साइज ऑफ एन एटम इज इंडिकेटेड बाय इट्स रेडियस। और जो साइज एटम की जो साइज है वो उसके एटॉमिक के उसके रेडियस से दी जाती है। नाउ ये कैसे कैलकुलेट होता है वो भी हम देख लेते हैं। सपोज suppose I here only that is the potassium 19 given. So if I want to draw the electronic configuration, so here will be the one electron. Then in the next shell there will be the eight electrons. In the next shell there will be the again eight electrons, and in the last shell there will be the one electron. I will draw it more perfectly. So that's one minute. We are having suppose given. Huh? So as here we can see that here we have given the diagram of the electronic configuration for the potassium. So if we are considering here that we can see two electrons, then eight electrons, then eight electrons, and then one electron. So atomic radius is calculated from the nucleus center to the last orbit electron present. So this is the atomic radius. And if we see that all are in the circular fashion, so it is approximately that it will be the radius of the circle only. This is the atomic radius concept, which we have seen. So now let's we have to think upon the latter part which is given. So now let's look at that. Atomic radius is the distance between the nucleus of the atom and its outermost shell. This is the important point which have to keep in the mind with the perspective of the exam and all that. And it is that only which I have told here that atomic radius is the distance between the nucleus of an atom to its outermost shell. That is the outermost shell. That means it is the valence shell. So this we have seen. So atomic radius is expressed in unit picometer, which is the smaller than the nanometer. So picometer is one picometer is equal to 10 raised to minus 12 meter. So atomic radius of each and every atom is calculated in the unit that is the picometer. सो ये यहाँ पर एक और सीखने जैसी एक बात है कि ये पिकोमीटर ये क्या है। सो दिस आर ऑल द मेजरिंग पार्ट्स विच यू हैव टू नो। सपोज सो हमारे पास यू कैन ऑल्सो नोट डाउन एट वी आर हैविंग द मीटर एट द सेंटर। सो स्टार्टिंग so here is the larger values and here are the smaller values, or we can take any according to ourselves that how the that measurements are. So deci, centi, milli, micro, nano, pico, femto, auto. Deci, centi, milli, micro, nano, pico, femto, octo. And deca, hecto, kilo, mega, giga, tera, peta, hexa, zeta, and yotta. So these are all the measuring which we can convert. So these are all goes in the 10 raised to 3. As we have seen 10 raised to 1, that is the meter, then 10 raised to 3, then 10 raised to 6, then 10 raised to 9. All the multiples of the indices are in the multiple of the 3. So as picometer is the very smallest unit. So it is the 10 raised to minus 12 meter. This we have to keep in mind. Some elements and their atomic radii are given here. So we are having the elements and the atomic radius given here. तो चलिए देखते हैं ऑक्सीजन हैविंग द एटॉमिक रेडियस है 66, बोरॉन 88, कार्बन 77, नाइट्रोजन 74, बेरिलियम 111, lithium 152. So these are all in the picometer. Picometer is 1 picometer is equals to 10 raised to minus 12 meter. So आगे क्या कहा गया है? You will find that the atomic radius goes on decreasing while going from the left to right within the period. This is again one important part which we have to focus. That you will find that atomic radius goes on decreasing while going from left to right within a period. When we are going from left to right within the period, so here, when we are moving in this direction, in this fashion, suppose sodium, magnesium, aluminum, silicon, and phosphorus, and all. So, what they are telling that when we move from the left to right in a period, so you will find that atomic radius goes on decreasing. मतलब जब left to right हम जब period में जा रहे हैं, तो we can see that atomic radius goes on decreasing. So atomic radius decreases when moving from left to right within a period. The reason behind this is as follows. While going from left to right within a period, the atomic number increases one by one, meaning the positive charge on the nucleus increases by 1 unit at a time. मतलब जब हम left to right जब period में जा रहे हैं, so we can see that the atomic number goes on increasing. और हमने ऊपर पहले इस चैप्टर में देखा था, यानी पिछले प्रीवियस वीडियोस में, कि जब एटॉमिक मतलब जो नंबर ऑफ प्रोटॉन्स और नंबर ऑफ इलेक्ट्रॉन्स जो है, तो वो है कि न्यूक्लियस के ऊपर चार्ज कितना प्रेजेंट है, पॉजिटिव चार्ज नेगेटिव चार्ज, आइदर पॉजिटिव और नेगेटिव. So as we can see that as the number of atomic number goes on increasing, मतलब पॉजिटिव चार्ज जो न्यूक्लियस पे प्रेजेंट है वो भी बढ़ता जाएगा. जैसे कि पॉजिटिव चार्ज बढ़ता जाएगा, increases by unit. However, the additional electron gets added to the same outermost shell. Due to increased nuclear charge, the electrons are pulled towards the nucleus. मतलब जैसा कि हमने पहले चैप्टर में देखा था ग्रेविटेशन में, कि एवरी ऑल द इन द यूनिवर्स ईच एंड एवरीथिंग which is present tries to attract everything. There is this the gravitational, suppose weak gravitational force exist कर रहा है, लेकिन gravitational force तो exist करता है. So that gravitational force, electrostatic force, these are all the forces which are also acting in the electron in the new atom nucleus, and electrons are also having attracting force, and the protons which are present in the nucleus also experience this kind of the force. So as we can see that due to this all force, the protons get attracted towards the nucleus, so which decreases the size of the atom, and due to this the atomic radius goes on decreasing in the period. This is the trend which we can see as of the atomic size along the period in a periodic table. So element potassium atomic radii is given, that we can see this, that lithium, cesium, rubidium, sodium, potassium. So potassium जो है ये तो सारे एक ग्रुप के हैं. जैसा कि हमने यहाँ पर देखा कि हाइड्रोजन, लिथियम, सोडियम, पोटेशियम, रुबिडियम, सीजियम, फ्रांसियम, these are all belongs to the same group. So we can see here that the atomic radius लिथियम, सीजियम, रुबिडियम, सोडियम, तो लिथियम का 152, सोडियम का 186, रुबिडियम पोटेशियम का 231, 244, 266. So these all we can see that the atomic radius goes on increasing while moving along the group of the periodic table. So some elements and their atomic radii are given here. So as I am focusing on the teaching part, so I will not able to answer all each and every comment. But after the completion of the part, so I will suggest you to write down the comments in the chat box. I will take the comments. So here we can see that you will find that while going down the group, the atomic size goes on increasing. This is because while going down a group, a new shell is added. Therefore, the distance between the outermost electron and the nucleus goes on increasing. As a result of this, atomic size increases in spite of the increased nuclear charge. So as the nuclear charge will be goes on increasing, so the protons that which are carrying the positive charge which are present in the nucleus will get attracted towards the center. So which will be able to decrease the size of the particular that element. So atomic radii will decrease, so the size of the atom will also goes on decreasing. So metallic and the non-metallic character, which we are going to see the next trend of the periodic table. So here we can see that look at the elements of the third period, classify them into the metals and the non-metal. On which side of the period are the metals, left or right? On which side of the period did you find the non-metals? So it is seen that metallic elements like the sodium, magnesium are towards the left. So in the periodic table, as we can see that the sodium and potassium elements which are so here we have seen that along the zigzag line, so there is the presence of the metalloid elements, and on the left hand side there are the metals, and on the right hand side there are the non-metals which are present in the periodic table of the as we have seen this in the periodic table, which is the structure of the modern periodic table. So what next? This is because while going down a group, a new shell is added. Therefore, the distance between the outermost electron and the nucleus goes on increasing. As a result of this, atomic size increases in spite of increased nuclear charge. And metallic and non-metallic character. The non-metallic elements as the sulfur, chlorine are towards the right. The metalloid element, silicon, lies in the between of these two types. As a similar pattern is also observed in the other periods. It is seen that the zigzag line separates the metals from the non-metals in the periodic table. That only I have told recently now to you. Elements appear to have arranged in such a way that the metals are on the left side of this line, non-metals on the right side, and metalloids are along the border of this line. How did this happen? Let us compare the characteristics, chemical properties of the metal and the non-metal. So as we have studied in the lower classes, that metals are showing the properties of the sonority and malleability and all, but non-metals are not having the similar properties. So it is seen from the chemical formula of the simple ionic compounds that the cation in them is formed from a metal while the anion from a non-metal. So as we have studied in the previous standards, that cation is carrying the positive charge and anion is the negative charge. So cation is the positive charge which is present on the metal, and non-metals are having the anion. So, due to which there is the formation of the ionic compounds. So, we have studied about the two types of the compounds basically. That is the ionic, and another one is the covalent. So, what asked here that from this it is understood that the metals have the tendency to form a cation by losing its valence electron. This property is called as the electropositivity of an element. मतलब जो मेटल की जो टेंडेंसी है कि वो इलेक्ट्रॉन दे सकता है, and another tendency that is of the anions having that they accept the electron, due to which there is a formation of the compounds as we have seen, that their formation of the ionic compounds are due to the formation of exchange of the electrons, that is the valence electrons will be given by the metal, and anions having the negative charge that will be the attracted by the non-metal. So due to this there is the formation of the ionic compounds. So तो एक definition आप लिख सकते हैं कि ionic compounds are the compounds which are formed by the give and take of the electrons, and covalent compound are the compounds which are formed by the sharing of the electrons. So on the other hand, an atom of a non-metal has the tendency to form an anion by accepting the electrons from the outside into its valence shell. We have already seen that ions have a stable electronic configuration of the noble gases. So noble gases, as we have seen, the 18th group, that is the zero group, which is there in the periodic table: helium, neon, argon, krypton, xenon, radon, and oganesson. So all these are having the means all these are octet is complete, duplet is complete. So they are at the stable cases. So due to that, they are called as the inert gases. They are also called as the noble gases, due to which they are classified at the 18 group. So here all their electronic configuration, that is the octet and duplet, is complete. So they are stable. So how is this ability to lose or accept the electrons in the valence shell determined? All the electrons in any atom are held by attractive force exerted on them by the positively charged nucleus. Electrons in the inner shells lie in between the valence shell and the nucleus. Because of their presence, the effective nuclear charge exerting an attractive force on the valence electrons is somewhat less than the actual nuclear charge. Thus, the number of valence electrons in the metals is small, 1 to 3. Also, the effective nuclear charge exerting attractive force on the valence electrons is small. As a combined effect of these two factors, metals have the tendency to lose the valence electron to form the cations having a stable noble configuration. This tendency of element called as the electropositivity is the metallic character of that element. So जैसा कि टॉपिक का नाम ही था मेटेलिक एंड द नॉन मेटेलिक कैरेक्टर which we are seeing. So ये कैसे होता है एक एग्जांपल से देखते हैं कि यहाँ पर सपोज वी आर फॉर्मिंग द NaCl कंपाउंड दैट इज द सोडियम क्लोराइड एज वी ऑल नो दैट it is the common salt that is NaCl. So Na is having the positive charge and Cl is having the negative charge. So Na के पास पॉजिटिव चार्ज क्यों और Cl के पास नेगेटिव चार्ज क्यों है? So that is the reason that Na sodium atom is having the electronic configuration as 281, which we have seen earlier that 2 8 और 1 जो कि Na का इलेक्ट्रॉनिक कॉन्फ़िगरेशन है एंड Cl का इलेक्ट्रॉनिक कॉन्फ़िगरेशन अगर हम देखेंगे तो 2 8 और यहाँ पर है 7. दैट मीन्स अगर इसने एक इलेक्ट्रॉन अगर Cl को दे दिया तो इसका ऑक्टेट कंप्लीट हो जाएगा और इसने अगर एक इलेक्ट्रॉन Na से एक्सेप्ट कर लिया तो इसका भी octet complete हो जाएगा. That means the 8 electrons in its outermost orbit, 8 electrons in its outermost orbit. So as we all know that every element tries to be stable. So to get stable, they should have to have their octet to be completed. So octet complete होना चाहिए. So that for that there is the occurrence of the give and take of the electrons. So NaCl तो हम बोलते हैं कि ionic compound form हो गया है. Na के ऊपर पॉजिटिव चार्ज, Cl के ऊपर नेगेटिव चार्ज. सो Na के ऊपर पॉजिटिव चार्ज इसलिए आता है क्योंकि वो एक इलेक्ट्रॉन दे देता है. इलेक्ट्रॉन दे दिया मतलब as we all know that sodium is having the I will find one blank space and so here. So as we all know that sodium ने एक इलेक्ट्रॉन अगर दे दिया, so sodium was having the that as we all know the atomic number of the sodium is 11, so it will contain the 11 electron and 11 proton, positive and negative. So एक इलेक्ट्रॉन दे दिया यानी एक नेगेटिव चार्ज दे दिया तो इलेक्ट्रॉन हो गए 10 लेकिन प्रोटॉन हो गए 11. So as the protons are positive are greater than the negative number, so due to which that Na is having the plus charge. और Cl का है 2 8 7 बराबर. So 7 electrons. तो Cl 17 क्लोरीन Cl है 17 इलेक्ट्रॉन 17 प्रोटॉन 17 प्रोटॉन से 17 इलेक्ट्रॉन से एक इलेक्ट्रॉन एक्सेप्ट कर लिया यानी 17 प्लस 1 हो गए 17 प्लस 1 हो गए यानी कि यहाँ पर अभी इलेक्ट्रॉन्स हो गए 18. So as the chlorine electron will be now 18 due to which that as electron is carrying the majority, so Cl will be having the negative charge. And when the positive and negative are there, so after that, after giving the one electron, it will be stable. After accepting one electron, it will be stable and will lead to the formation of the sodium chloride that is the ionic compound. This is the theory behind this. So now we will look uh, forward that here we have given some trends that decreasing atomic radius as we have studied all about this in the upper part. This is only the diagrammatic representation which is given here. Decreasing atomic radius जैसा कि हम यहाँ से यहाँ पर जाएंगे मतलब पीरियड में ट्रेवल करेंगे तो एटॉमिक रेडियस डिक्रीज होती जाएगी. इंक्रीजिंग इलेक्ट्रोनेगेटिविटी as electrons will be added, atomic number goes on increasing. Non-metallic character because we are moving towards the non-metals and decreasing electropositivity. आसानी सी बात है कि अगर इलेक्ट्रोनेगेटिविटी अगर इंक्रीज हो रही है तो इलेक्ट्रोपॉजिटिविटी विल बी डिक्रीज and the metallic character also decreases as metals. Here we are having the non-metals at the right hand side and metals at the left hand side. So along the group भी देख लेते हैं, increasing atomic radius, down the group atomic radius will goes on increasing, decreasing electronegativity, non metallic character. यहाँ पर सारे तो metals ही है, उसकी वजह से इलेक्ट्रोपॉजिटिविटी बढ़ती जाएगी और मेटेलिक कैरेक्टर बढ़ता जाएगा, इलेक्ट्रोनिगेटिविटी कम होती जाएगी और नॉन मेटेलिक कैरेक्टर भी कम होता जाएगा. So these are all the trends. तो उसके बारे में देखते हैं. The periodic trend in the metallic character of the elements is clearly understood from their position in the modern periodic table. Let us first consider the metallic character of the elements belonging to the same group. While going down a group, a new shell gets added, resulting in increase in the distance between the nucleus and the valence electron. This results in lowering the effective nuclear charge and thereby lowering the attractive force on the valence electron. As a result of this, tendency of the atom to lose the electrons increases. Also, the penultimate shell becomes the outermost shell on losing the electrons. The penultimate shell is a complete octet. Therefore, the resulting cation has a spatial stability. Due to this, the tendency of the atom to lose the electron increases further. The metallic character of an atom is its tendency to lose the electron. Therefore, the following trend is observed. The metallic character of the element increases while going down the group. So while going down the group, the metallic character will goes increasing. एक और बात थी यहाँ पर, अगर हम एटॉमिक रेडियस जो कि हमें यहाँ पर दिए गए थे, so if we see the lithium atomic radius 152, sodium 186, potassium 231, rubidium 244, cesium 260. So we can see here that the atomic radius goes on increasing as a large. So due to which the distance between the nucleus and the outermost shell will goes on increasing, due to which the force acting of the nucleus on the valence electron will also be less. So due to which the it is easy. It is the tendency of the metals to lose that valence electrons, and it is the tendency of the cation, that is the non-metals, to accept that electron and form the stable compound. So that is only we are seeing. So while going from left to right within the period, the outermost shell remains the same. However, the positive charge on the nucleus goes on increasing while the atomic radius goes on decreasing, and thus the effective nuclear charge goes on increasing. As a result of this tendency of the atom to lose valence electron decreases within a period from the left to right. The two factors, namely increasing the nuclear charge and decreasing atomic radius as we go from left to right within a period, are responsible for increasing the effective nuclear charge. Therefore, the valence electrons are held with the greater and greater attractive force. This is called as the electronegativity of an atom. Due to increasing electronegativity from the left to right within a period, the ability of an atom to become anion by accepting outside electrons goes on increasing. The tendency of an element to form anion or the electronegativity is the non-metallic character of an element. That is only the metallic character is the tendency of an metal to lose the electrons. That is the metallic character, and tendency of an element from the anion or the electronegativity is the non-metallic character of that element. So always remember we are given that while going down inwards in the group, electropositivity of the elements goes on increasing while their electronegativity goes on decreasing. These are all that which we have seen as per in this diagram, that only points are given in the always remember section. So gradation in the halogen family. This is again one important point which we are going to see. तो क्या gradation आता है? The group 17 contains the members of the halogen family. As we have seen in the periodic table, that is a modern periodic table, we are having here 17 group that we are calling as the halogen family. That is fluorine, chlorine, bromine, iodine, astatine, tennessine. Mhm. So all of them have the general formula, that is the X2. That is suppose F2Cl2 Br2. A gradation is observed in their physical state down the group. Thus fluorine F2, chlorine Cl2 are the gases. That means fluorine and chlorine are the gases. Bromine Br2 is a liquid, and iodine I2 is a solid. So this is the gradation which is observed, that in along the halogen family, the fluorine and the chlorine are the gases, bromine is the liquid state, and iodine is at the solid. Why they are showing the Cl2 only? So, as we have seen here, that their valence means suppose बात हो so, suppose we are taking that F2, F2. So fluorine has the 9 fluorine atomic number. So that will be the 2 and 7, correct? And we are again taking the fluorine that will be also having the 2 and 7. So this is needing the one electron to complete its octet. This is also needing the one electron to complete the octet. So they share their electrons with them. So formation of their outermost configuration will be that they will share the one electron. After sharing of this one electron, the fluorine will be able to complete its octet. Again, one fluorine will able to complete the octet. And due to this, they will be forming the stable compound. So that's why fluorine, chlorine, that are the F2, Cl2, Br2, I2, and all. So we are having, do you know that M plus 2H2O gives MOH2 plus H2O? This is one reaction which we have given. So what is about this reaction? A general chemical equation indicating the reaction of alkaline earth metals is given above. While going down the second group, that is the beryllium, magnesium, calcium, strontium, barium, the gradation in this chemical property of the alkaline earth metal is seen. While going down the second group, the reactivity of the alkaline earth metal goes on increasing, and thereby the ease with this reaction takes place along also goes on increasing. Thus, beryllium B does not react with water, magnesium reacts with steam, calcium and strontium and barium react with the water at the room temperature with increasing rates. So these are all the periodic trends which are observed, but these are specific to the group, as we have seen the trend here in the halogen family, and we are again seeing the trend in the group 2, that is the alkaline earth metal of the S block. So that we are seeing that when the metal M when reacts with the hydrogen, forming the metal hydroxide, that is OH twice, and releasing the hydrogen gas. So the behavior of this has been studied about the elements of the beryllium, magnesium, calcium, strontium, and barium as per the as per the experiments and all. So it is observed that beryllium does not react with the water, magnesium reacts with the steam, and calcium and strontium and barium reacts with the water at the room temperature with increasing rates. So here we complete with the chapter 2 of Earth. So as I have explained each and every part, you can be able to answer all these questions. And if having any doubt, then you can comment. So if you are having any kind of the doubt, so you can answer in the comment box also regarding with that, as we will be completing all our chapters in the live part only. And if you have any doubt regarding to any concept, then also comment in the chat box and also comment in the uh, under the video also, so that I could be able to answer all of the questions of yours and your doubts will get solved. So now we will stop here, and from the next video, we will start with the chemical reactions and the equation, our third chapter. So if you are having any doubt, you can also put it in the live chat also. So now we will stop here and we will continue with the chapter 3.